everyone. It's very nice to be there with you for this presentation. Let me introduce myself to you. I'm Mr. Ahmed Mustafa. I'm going to be your math teacher today for our new lesson, which is differential calculus. But first, we need to know what is the meaning of calculus. Calculus is the branch of mathematics that deals and studies continuously changing quantities. And calculus involves two branches of mathematics. The first part is differential calculus or differentiation, which we're going to learn it today in today's video, and integral calculus, which is integration. So, concerning the differential calculus arises from the study of the rate of change of a function, usually denoted by y or function of x. So if y equals function of x, the most common way of expressing its derived function, or as we usually call it, the derivative of a function, is dy by dx, or you can just say derivative of x, or f prime of x, which means the first derivative of x. Okay. So derivatives. How can we find the derivative of a function? The most basic rule we need to know is the general formula for the relation between a function and its derivative is the derivative of a variable raised to a constant such as x raised to the power n is going to be equal to, here we're taking the derivative of x raised to the power n. Look and check it out, okay? So this is going to be n times x raised to the power n minus 1. What happened here in this function, in this derivative? As you can see, we dropped the n times the n from the power times the base, and we subtracted 1 from the power. So it gives n times x raised to the power n minus 1. So this is the general formula of the derivative to find the derivative of a function. Okay. Let's say how can we do that on examples? Okay. Let's say if we have y equals x squared, to find the derivative dy by dx, as we said, or you just can say f prime x or derivative of x or etc. Okay, so the n is 2, so it's going to be 2 times the base, which is x raised to the power 2 minus 1. We subtract 1 from the power, so it's going to be, or just 1. As you can see here, this is going to be equal to 2x only, as a result in the end of that. So, can we get the second derivative of this function? Yes, we can. So, to find the second derivative of 2x, so 2 times the n power here n is 1, so 2 times 1 is 2, and times the base, which is x raised to the power 1 minus 1, which is equal to 0, and x raised to the power 0 is going to be equal to 1. So we get 2 as a result in the end of this example, okay? Let's pick another one. Here's y equals x cubed. So to find the derivative, the derivative of x cubed by dx equals, and here n is 3, so it's going to be 3 times the base, which is x raised to the power 3 minus 1. So it's going to be 3x raised to the power 2. Only as a result in the end of this method, and so on. This is a simple process in which you can find the derivative of a function. Okay. And now we'll proceed this idea on some physical application, which the independent variable is often t, time or time, and the dependent variable is s. So if s equals function of t, then ds by dt, or f prime t, or we can say derivative of t, represents the rate of change of distance with the rate of change of time. In other words, which means velocity. So that equals to v, which means velocity. So velocity. Let's apply this idea in an example, okay? So here we got s equals t squared plus 4t. To find the derivative of this equation, or I mean this function, ds by dt, or we can just say v equals, now we apply the derivative, find the derivative. Here n is 2, so it's going to be 2 times t raised to the power 2 minus 1, which is 1, so it's going to be 2t as it is, plus 4t, which is 4 only. This is the velocity. This means velocity. Okay. And if we try if we attempt to find the initial velocity for this equation, we have to substitute t by 0. So if you are trying to find v naught, it's going to be equal to 2 times 0, which is 0, plus 4, which is 4. So the initial velocity is going to be equal to 4. Okay, let's take another example. Okay. We have s equals 6t plus t raised to the power 5 over 5 minus 2. Okay. We plugged in an example for this point, and we're trying to find the derivative of the distance. Okay? To find the derivative, for the time in this function. So derivative of s by dt, or which means velocity, is going to be equal to 60, which the derivative of this term is going to be 6 plus t raised to the power 5, which is 5 times t raised to the power 5 minus 1 over 5 as it is. Minus 2 is going to be equal to 0. Yes, I didn't mention that, by the way. If you're trying to get the derivative of a constant, it's going to be equal to 0. So again, if you're trying to find the derivative of a constant, it's going to be equal to 0. Okay. So v equals, or velocity equals 6 plus 0, which is 6 as it is. So 5 cross out with 5, so it's going to be equal to this plus t raised to the power 4. Okay, t raised to the power 4. This is the velocity of this equation, the function. If we're trying to get the v naught, or initial velocity, it's going to be, we substitute every single t with 0. So 6 as it is plus 0 is going to be equal to v naught equals 6 only. That's it. Okay. Speaking of physical application, if we're trying to find another thing like acceleration. So acceleration is the change of velocity by time. So acceleration is going to be equal to dv by dt, the change of velocity by the change of time, right? Yes. Okay, let's plug in an example for this point, and it's going to be the last one, by the way. S equals t cubed plus t squared minus t inverse, or raised to the power negative 1. Okay. If we attempt to find the acceleration, we have first to find the velocity and then get the derivative of the velocity to find the acceleration. Yes. Okay. So velocity equals, here n is 3, so it's going to be 3 times t raised to the power 3 minus 1, which is 2. Great. Okay. Plus t raised to the power 2. Here n is 2 times t raised to the power 2 minus 1. 2 minus 1 is going to be equal to 1. So let it as it is. Okay. This is negative or minus. And this n is equal to negative 1. Negative 1 times negative 1 is going to be equal to, it's going to be plus. So this is time t raised to the power negative 2. We subtracted 1 from the power here. So negative 1 or minus 1 is going to be negative 2. That's it. So velocity, as you can see, here is equal to this the right hand side. So if we're trying to find the v naught, it's going to be equal to 0 plus 0 plus 0 is equal to 0. So this vehicle started its speed from 0 kilometers. So if we're trying to find the acceleration, if we're trying to find the acceleration, so we're going to make another derivative, or the second derivative of t. So dv by dt is going to be equal to this expression. So 3 times 2 is going to be 6 raised times t raised to the power 2 negative 1, which is 1, as you can see, plus 2 times t, this is going to be 2 only, and this one is going to be, we drop the power, which is negative 2 times t raised to the power negative 3, negative 2 minus 1, which is negative 3. So this is how we can get the acceleration from a function related to distance. Okay, and here we reach the end of this video, and that's all for today's lesson, and I wish you all understood. Thanks for all listeners and for the Academy. See you next time in another video with another lesson. Yeah, goodbye.